Hello everyone. Today I'll be teaching you the variable separation method for solving a differential equation. So variable separation is a method where you basically separate the function into function of x dx equals to a function of y dy. So what I mean is if you have dy by dx equals to a function of x comma y, then you turn this into a function of x dx equals to a function of y dy. So the best way you guys can understand is through some examples. So let me grab a question right here. So a simple question, x dx plus y dy equals to 0. So here we can just take this part to the right hand side. This means x dx equals to minus y dy. And now we can simply integrate both sides. Now we can put this minus outside, and the integration of x dx is x squared by 2, which is equals to minus y squared by 2 plus c. Now this is a constant, but we can also write this because in the end this is also another constant. It does not matter. You can choose ln c, e to the power c, sin c. It does not matter. They are all constants. So you may ask, if there's a constant here, so why isn't there a constant here? Because, well, if we let's say put plus c or c dash, then we can put that in this side, and a constant minus a constant is just another constant. So in the end we all get a constant on one side of the equation. So in here we can see that we can take 2 common, and this will divide with that. So we'll get x square equals to minus y square plus c square. Therefore we'll have x square plus y square equals to c square. That is the answer. Now let's see another question which involves some trigonometry. So root 1 minus x square dy equals to root 1 minus y square dx. Now we have to put the x terms with dx and the y terms with dy. Now always make sure that dx and dy are always at the numerator, because that is the only way we can integrate something. So this becomes dy by root 1 minus y square equals to dx root 1 minus x square. Now we integrate both sides. So what is this? 1 by root 1 minus x square. Well, this is the sine inverse x, because derivative of sine inverse x gives us 1 by root 1 minus x square. You can prove it by putting x as sine theta, and then this will be cos theta, you will cancel out, you will get theta, and theta will be inverse equals to sine inverse x. So in the end you will just get sine inverse x. And for the same, you get sine inverse y equals to sine inverse x plus, let's choose c1 for now, then sine inverse x minus sine inverse y. So this will go here. We have the c1 right here equals to 0. Now what we can do is put that constant on this side. So this will become minus c1, but again minus c1 is another constant, so we can write it as just c2. So we have sine inverse x minus sine inverse y. Now this is a inverse trigonometric function or identity. So this will be equals to sine inverse of x root 1 minus y square plus y root 1 minus x square equals to c2. I think this is minus, because you can think of it as like sine a minus b in the bracket, which is sine a cos b minus cos a sine b. So we have sine A, cos B, so cos root 1 minus sine square B, y, and that. And what we're going to do is put the sign over here, so it's x 1 minus y square minus y root 1 minus x square equals to sine C2. But again, like I said earlier, sine C is just another constant, so we can just write it as C, which was originally equals to sine of C2. Now this is the required answer. Now time for another one which requires some integration knowledge and some trigonometry as well. Tan x dy equals to tan y dx. Now we know what to do. Dy by tan y is equals to dx by tan x, and we integrate both sides. Let's make it simpler for us. Let's put this above, so this becomes cot y dy equals to cot x dx. Now what is the integration of cot x? Well, if you want it directly, it is log natural of sin x. But let's actually prove it here. Why? So if we have integration of cot x dx, this is just cos x by sin x. You can let u equals to sin x, then du equals to cos x dx. So you have the integration of du by u, which is ln u, which is ln sin x. You can also write this as a derivative of a function x by function, which is the log of the function, and here the function is ln sin x. This is an identity. So from here we have ln cot y equals to ln sin y equals to ln sin x, plus you can choose a constant, but to make the answer nicer you can put ln c. Now let's choose ln sin y minus ln sin x equals to ln c. Now with the log property, we know that ln a minus ln b is ln a by b. So we have log natural of sin y by sin x equals to ln c. Now here we can cancel the ln on both sides. So therefore we have sin y by sin x equals to c. Now I think we have time for one more question. Now, to solve variable separation, you only need some basic algebra knowledge and derivatives and integrations. So what can we do here? How can we just get function of x dx, function of y dy? Well, we can see here, we can take x common, so let's do that. Just write 1 dx plus y x square plus 1 dy equals to 0. So what we can do is put that on the right hand side, so we get x y square plus 1 dx equals to minus y x square plus 1 dy. Now we can see that we can put the x square plus 1 down here and the y square plus 1 down here. So we will get x by x square plus 1 dx